All right. Greetings, everyone. Welcome to the last day of August 2020. Um, I'm actually recording this on Saturday, getting ahead of the game, and just want to go over your second week content and assignments. Um, got a really good foundation this week to talk about big data, and that's the concept of a smart city. So we'll get started. Uh, I wanted to go back and do a little bit of overview. Um, the first week was kind of just setting the stage, and all of that content was recorded from previous semesters. I'm actually recording this one for fall 2020, section 50. So I wanted to go and make sure that you guys are have found the textbooks in the week one folder and are at least scanning the first chapter or two of data science and big data analytics. So we'll go over a little bit about this stuff, this big data stuff, um, and then I use the word practice there. It is not practice, but it will be good practice for your dissertation, your research paper this week. Okay, so moving into the course content, this is this whole world of big data. I apologize if you are all fully aware of this terminology, but it sets the foundation for the course. So if any of you are Hadoop or Spark or doing like very largely scaled MongoDB implementations, could you please shoot me an email? I don't work in big data. I've worked in normal data, relational data, analysis for years, but not big data. I'm trying to get up to speed on it. But if you're in that world and can provide some insight to the rest of the class, um, that would be great. Please contact me. It doesn't look like it. Looking at your vague introductions, some of you didn't really tell us anything about yourself. Um, but if you are in big data, please let me know. Please contact me so we can work together on some sort of information sharing and presentation for the class where we'll all benefit. But anyway, the three V's of big data. I've done one big data project in my life. I'll talk about that throughout the course a little bit. But the characteristics of big data um, are uh, these are classic, going back some 10 years. Extra credit for anybody who finds the original first article that defined the first three V's of big data. There's lots of V's out there. So we've got uh, volume, which is just the we'll go into each of these individually. Just the sheer amount of bytes on disk, just pure sheer size. And then you've got the variety, a variety of sources, a variety of data types. Um, and then you have velocity, the speed at which the data is coming to you and the speed at which you have to operate for that data to be relevant. Um, if you're analyzing social media from 2 years ago, may not be so relevant about anything at all. Might be okay for trending or sociological, but if you're trying to make business decisions or even governmental decisions, you have to keep up with the velocity of data. And as I said, teaser, there are a lot more V's. Everybody, once you see something like this published, there's a bandwagon approach. Everybody tries to jump on the bandwagon and extend um, an existing framework or an existing buzzword. That's what you're seeing now, and we'll talk about a couple more that are seeing prominence in the literature. So those are the three. Volume, man, volume of data. When I got into computers in the late 80s, a lot of the the truly large data sets like the US census that was conducted every 10 years, when that became uh, uh, digitized, in the 60s, it was on tape, on those giant magnetic reel tapes that you had to have a computer operator load, and the mainframe computer could read it in, and then you'd have to load another data tape, and it didn't really hold very much. And just the size of files has grown dramatically in your lifetimes. I think I got into IT uh, before or right around when most of you were born. Um, it's just it's changed dramatically. And then there are people that are 20 years older than me that have even more impressive stories to tell. But yeah, the volume of data is increasing because the number of things generating data and storing data is increasing like crazy. I mean, just the units of measure are changing faster than there was a long time all you needed to know was a gigabyte, and actually most of the stuff was in megabytes for decades. And then all of a sudden, terabytes became not such a big deal, and now you can get a terabyte drive for I don't know what, $40, crazy. And then petabytes and exabytes, and uh, I can't remember what comes after that. Yeah, but it's getting to be just ridiculous, the amount of digital data out there because of mobile devices and their applications. You know how modern society is. People are staring at their phones constantly, and that's all generating data, whether they're tapping on the screen or not. It's generating location-based data. It's generating data within the wireless carrier's network. It's generating packets going back and forth, which are data. Um, you've got IoT devices. Everybody's got an Apple Watch and an Alexa, and smart homes, and then you've got smart manufacturing and RFID chips, and on and on and on. You've got cameras of every type, cameras on every cell phone, cameras on every corner, stoplight cameras, police body cameras, security cameras, cameras watching manufacturing uh, uh, processes, um, news cameras, cameras in space, weather satellite imagery. Um, you know, Healthcare devices are generating data all the time, and it just contributes to an enormous volume of data. And Moore's law is that space disk space tends to increase exponentially, and decrease in price exponentially. Um, and then to make room for this, you've got cloud computing, where you have somewhat of an economy of scale. Instead of trying to put this information on individual disk drives, you've got a much better chance with the elasticity of cloud computing. Then there's next generation disk drives, where they're trying to figure out how to put more space on smaller, more stuff, more information in smaller form factor. So yeah, the volume of data is a challenge um, that we're trying to address, and a variety of data. There was a time when pretty much everything was flat files, um, like back in the COBOL mainframe days, and structured data. Flat files are very structured, rigidly structured. I'm still dealing with flat file format now when I report student information to the state Department of Higher Education. That reporting mandate is in the form of a fixed length flat file where each field is fixed length. So each number of characters, character 1 through 39 is student name, say, and then 40 through 50, 40 through 49 is something else. So that's still being done. And then good old fashioned normalized relational data, as in Oracle or MySQL or SQL Server. So you've got structured data, then you've got semi-structured data, tagged data, within which it can be pretty unstructured, though. I mean, you've got tags, but inside of those fields, you can have pretty huge chunks of text that aren't structured, like you can get tweets in JSON format. Semi-structured, the date of the tweet. You can pull out hashtags, but the rest of the text would have to be mined as unstructured data. And then you'll see the term quasi-structured, which is supposedly structured, but often has errors and flaws in the data, so dirty data. And then you've got unstructured data that's just full of information, but requires processing, lots of processing to pull any real value out of it. Unstructured data, and that's in the form of documents, which can be mined for keywords, and you can use natural language processing to pull information out of documents, like um, everybody saw Watson on Jeopardy, right? Well, one of Watson's largest knowledge bases was Wikipedia, and it learned how to bounce through Wikipedia and guess answers based on text mining of those HTML documents. And then images. There's lots of information in images. I was watching a seminar recently. There's a Python library that links in with an external library where it'll pull text, recognize text in an image, and pull it out as data. So you could in theory use the Google Street View car images and start pulling. You could pull text off of mailboxes. You can pull text off of billboards, off of people's T-shirts. Think about how much information goes by a camera, like at a parade or a political rally or something like that. Um, there's just a lot of information in images, and a video is just a bunch of images, one after the other. You combine the image recognition, like you know, there's software that can recognize a 2012 Honda Accord. That can recognize license plates easily. And then you combine that with location data, and you have the what and the when and the where from this imagery. Uh, Facial recognition adds the who, what, when, where. So yeah, there's just a lot of different types of data out there, variety. And then velocity. This refers to the speed at which the data is arriving. Say if it's arriving at an application or arriving at a data science project. um, Velocity, this data is coming in real time, and it's changing in real time. You have real time systems and sensors. Now, just because it's real time doesn't something is real time doesn't make it a big data project, really. I mean, if you think about it, the dashboard in your car is a real time information system. It's telling you the current time. The dashboard on your car tells you your current speed. If you've got your GPS up, it tells you your current location. But that's all fairly structured and focused, and not really doesn't really incorporate these other V's, right? Just because it's coming at you in real time. So yeah, it, it's coming at you in these different types uh, at at real time, and you have to be able to process the velocity. You know, there was a time when it was okay to process a transaction overnight. You know, batch processing. And anymore now, everyone wants everything right now. They want transactions to be processed with uh, speed. Social media is generating sentiment at speed that can be analyzed and monetized. Everybody has a mobile device on them right now, providing this, you know, this constant real time update of data, and you've got to be able to deal with that velocity. I mean, you know, think of how many people are ordering Amazon Essentials at any one point in time in that company. That would be an interesting data point. What was the single most ordered item yesterday on Amazon? The single uh, most appealing, most wanted inventory item. I don't know that I've ever looked that up. So there you go. Now, I like to use this slide. It just highlights what we're talking about, a day in data. And some of these aren't necessarily a day's worth of things, but some of them are, you know. And this comes from, I believe this slide came from 2016 or 17. And every once in a while, um, I think I'm going to find a better one, but I always come back to this one. So, you know, billions of emails, tweets, how much data per day is generated on these different platforms. Oh, and I put a a um, a video from YouTube. It's actually a public broadcasting system PBS special called Nova. They do all kinds of scientific and sociological um, documentary sort of pieces, and there's one in the classroom in week two about drones, and one of them is an experimental drone being developed by the United States government that collects just a staggering amount of data every day, and not only raw video data, but um, there's a ground station that processes that video and you know adds information about what the video is seeing as far as the position of everything and its classification. It can tell a bird from a car, from a person, from a tree. It's just incredible. And you know what they say about the laboratories, 20 years ahead of reality. So if that thing's already operational, you know what the bleeding edge stuff they've got in the laboratory is probably scary. So anyway, I like this slide. It kind of highlights the whole big data challenge. Exabyte. Oh, zettabyte. Yeah. And then yottabyte. You ought to buy some more hard disk space if you want to store yottabyte. That's funny. I can't hear anyone laughing, but I know in my heart that was funny. Okay, so the analytics life cycle is very people oriented. I just wanted to throw this out there. You'll see these roles defined slightly differently depending on the company. But every data science project starts with a question. Um, there are business questions. What's my best selling product? The you can look at the descriptive analytics that talk about what happened. What was my best who was my best salesman last quarter? How many miles did we put on the uh, the fleet last quarter? And you know, air miles or ground miles for cars or operating hours for equipment. So describing the past. Um, Everything starts with a question, whether it's asking about what happened in the past, what's happening right now, like right now, what's the trending topic on Twitter? That's gettable. They publish it. And then you've got the prescriptive, predictive side of data science that asks what's going to happen in the future based on current trends. What's going to happen based on current trends and typical seasonality? What's going to happen in the future? What's going to be the hottest selling product next year? Um, you can combine multiple trends and see how those trends might have indicated things in the past and learn from it in the future. But every data science project starts with some sort of question, and then you go find the data or start collecting the data that you think will address those. Um, but you got to have the people in place in any kind of organization, in any kind of um, larger scale fashion. So the textbook will tell you that a data science project begins with these roles, and some of them are combined, and they're not necessarily. Some of them are very formally defined, others not so much. But you've got the business user, the person um, that knows the end line business, often generating the data. Project sponsor is like a leadership role. Someone in management has to care about your data science project, or you wind up kind of going at it, and when you provide the answer, no one really cares or acts on the recommendations. So it's always good to 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 have sponsorship, where someone with influence actually cares about the results. That's different than the project manager, who's actually just making sure that the things you have to do in a data science project, the acquiring the data and cleaning it and managing the requirements of the questions and what data satisfies that, and which programmers and which analysts are going to do what when, and managing a large data science projects not unlike managing a software development project. In fact, you're probably going to be developing software as part of that data science project. So you need a project manager, PMP or someone like that. A business intelligence analyst can often be a bridge between business users and data scientists. That's a role. Business intelligence is really just kind of pulling data out of the enterprise and looking at key metrics, so that you can make decisions on them. DBA is a database administrator. Again, that role is fragmenting, but the DBA used to be the guy that gave usernames and permissions, but he also was the tuner that could report on the performance of queries and whatnot, and recommend if we need to add resources. There are ways um, to add um, more processes to a query, uh, add more grunt if it's cloud based. So yeah, DBA is a database administrator. Then you've got the data engineer. That's a kind of a fairly new role, but this is the guy, kind of like the data wrangler, that is worried about data quality and data source and pulling the data together. I'm seeing data engineers in job ads that are the person that's doing a lot of like the ETL and cleansing and creating, from data warehouse, either creating a data warehouse from a data lake, or uh, creating a data mart, a focused schema from a data warehouse. But they're working hands on with the data that gets fed into an analysis project, and then you've got the data scientist. This is usually the person that's best on methodology. Whether it's machine learning or applied statistics. that can make sure that the methodology is sound when it comes to the project itself. And and then you've got a life cycle of a data science project, kind of like the life cycle of a software project. Discovery is just deciding what is it that we want to do, uh, and it can involve data mining to see what data you even have, just to make sense of what there is before you can even ask a question that's kind of in parallel. You don't want to go asking specific questions of data that you don't understand, and you don't want to go into data assuming anything. So anyway, discovery is kind of parallel. What do we got here, and what can we do with it? Data prep is cleaning and getting the data. No duplicates, no nulls, no bad values. Hopefully not no outdated information. Hopefully, model planning and building, that can be as simple as linear regression or as complex as a 60 factor machine learning algorithm. So those in the middle are kind of how are you going to apply that data against some problem? And then communicating the results, that's huge. Huge. If you cannot clearly and concisely report the results uh, back to that project sponsor, you're wasting your time and you are useless to the project as a communicator. You need to make sure the project has someone that can communicate it. And if you are a standalone data science guy and you're responsible for communicating your own results, make sure you're good at it, whether it's appropriate visualizations, using the right amount of text, the right granularity. You don't want to throw too much at the audience. You want to be fair and balanced. There's a lot to communicating the results of a data analysis project, and then operationalizing it. Hopefully, unless you're just a pure research institute like Pew or Gartner or maybe the Congressional Research Service, MITRE. Um, you're probably in an organization that wants to do something with the results of that data science project. So that's what operationalizing it is taking the results of that and feeding it into some future decision to increase something or decrease something based on the results of the data analysis project. So just some background, just some overall background in this course. But specific to week 2 is that sort of big data challenge when it comes to the notion of a smart city. Now, this graphic comes straight out of the week 2 folder, and there's a little blurb in there about what makes a smart city. Well, we don't really have a perfect uh, definition of a smart city, but it is incorporating there. You'll see definitions by various authors out there in textbooks um, and articles. But anyway, it's using information systems and communication systems uh, to control, to govern the infrastructure and the people uh, within an urban environment. And we have some cities on the planet are packed full of people and have absolutely zero automation, and then you've got some that are pretty smart uh, all around the world. You've got examples of smart city implementations. You just go out to Google Scholar and type in smart city. You'll start seeing journal articles for all of this stuff. Yeah, scheduling waste management so that you don't, you're not driving empty I'll start in the upper left corner and go clockwise. Uh, um, Garbage collection, smart health. Uh, that's its own topic. We've got a week on big data and health. Um, uh, Parking for cars. Hopefully that's going to go away fairly in the next 20, 30, 50 years. Um, where, a car pulls up when we on demand, transportation on demand. And we'll all go around in Johnny cabs like in the Arnold Schwarzenegger movie. But for now, smart parking lets you know who's what before you even pull up to a parking garage and waste your time driving around looking for a parking spot. It could tell you where there are places to park. Of course, online education. I'm not. That's too broad to even go into. Public safety. Where are crimes occurring? There are gunshot sensors. Uh, um, there's crime, historical crime data, real time 911 calls. A an officer's squad car is a big data exercise right there. With outstanding warrants, and they can feed video from drones and helicopters into the squad car so that they can see things. Smart buildings that incorporate a lot of these different technologies as far as um, their heating, ventilation, and air conditioning. There are even buildings that will shade themselves or not shade themselves so that they can take advantage of the angle of the sun and the heat that it generates in the winter, or hopefully the shade on the sunny side of the building, you know, in the summer. Traffic management is another example you'll see out there. Um, uh, Timing streetlights. That's another one on the opposite side. Smarter. Well, no, that's not. Those are illuminating streetlights. Anyway, traffic management, stoplights, green lights, yellow lights, those kind of things. Um, Opening up roads to one way based on demand. That all feeds in to smart city traffic management, smart energy grid, um, and other utilities like gas and water, and um, uh, smart shopping, so people know what inventory levels are. Think of the traffic that could be cut down if everybody was fed information about the likelihood that they're going to get what they're shopping for at a given location. I've certainly gone somewhere and they're out, ah, driven away. Smart homes, air pollution. Eventually, we're going to get to electric vehicles pretty quickly here, according to the industry experts. Of course, smart streetlights. There was a time when a guy actually walked around, and then we did human intelligence to light the streetlights, and now we use photovoltaic cells and even like um, you know sensors that detect motion. You're walking down the aisle of it. It's not a street light, but you're walking down the aisle at the grocery store. We're saving energy by not lighting up things that has no one in it. And we've all gone into a bathroom and thought the light was out, and all of a sudden it comes on because it sensed your motion, which is disconcerting if you're in the bathroom and for some reason you don't move for the 20 seconds and it turns the automation turns the light out on you. So anyway, so smart city, that's what this week's paper is about. Is the concept of a smart city, and what is data doing for people. You've got fairly advanced cities out there, um, uh, Singapore, Shanghai, Stockholm, Sweden. You've got, um, again, there is no specific definition. There's no specific protocol. There's no one technology. A lot of this, some of this stuff is in the hands of the government. Some of it's in the hands of private individuals or businesses, the people that own and operate these buildings. Um, But uh, as with anything else, internet related, things start to connect to each other, right? They start to get smarter about each other and share data and share information and share uh, applicability. So that's what you're starting to see with these smart cities. Places where you can go and you can pay for your parking meter using your smartphone. Booyah! There's one application right there. And then there's other places that, man, if you don't have a quarter to put in the meter, you'll get a ticket, and that's just terrible. So, so there you go. Uh, the smart city and big data, and a lot of this is real time, but some of it is after the fact, analyzing data so that you can make planning decisions on where you're going to grow, or maybe uh, what roads you're going to use, or where there is demand for certain things, maybe where you're going to zone more restaurants or more retail outlets, more parks. So all of this can be used in real time to operate the city, but it can also be used for planning the future development of the city. And maybe we don't want to give another building permit for workers because we don't have enough housing. Maybe we have to manage the growth of the city and not just let it let it grow uncontrolled. That's for the folks in government. We are data scientists, and we just provide data and the resulting analysis of that data. All right. So that's this week's subject, as far as the particular domain of the big data analysis. Okay, so your week 2 research paper. Um, I attached a sample paper. Okay, so the requirements for this paper, the instructions are specific on the classroom page. I want you to read the instructions carefully. I'm looking for, uh, as I always will, I'm looking for you to cover the instructions specifically. I don't ask you to just write anything you want about smart cities. I'm not asking you to just write anything you want about big data. Okay, read the instructions and focus on them, and write according to these instructions, and you'll be fine. So these are short papers, guys. These are 20 points each. Don't take a lot of time with background stuff. Okay, 2 to 3 pages in length. No table of contents, please. No abstract. Um, use use the template paper I gave you, or a blank Word document. Don't use any other paper from anywhere else, from anything. Don't even use previous papers you've written, please. Um, we changed to APA 7, guys, but a uh, I'm not terribly worried about APA format, uh, especially the details. You need to be aware of those changes, and as you approach your dissertation, that's the big test. You don't want to get going too far into your dissertation, of 100 pages, using the wrong technique. So make sure you're paying attention to APA. Um, as in my template, you should have a short introduction, a body where you fully developed the idea, and a conclusion paragraph, and use section headings. There are examples of them in the paper I posted along with your assignment. Um, Section headings keep you on track, and like in the academic writing for systems engineers video that I posted, I would use an APA paper, and I would just delete everything but the headings, and I would use that as my outline, and then I would type in my thesis sentence in the introduction, And then I would begin under each heading. I would begin a a paragraph with my topic sentence for that paragraph, so that I could stay nice and organized. You will find very quickly that I demand organization in your papers. Don't repeat yourself, and don't bounce around from idea to idea without, any rhyme or reason. Keep your paragraphs cohesive to one main idea, um, or you're just not going to be happy with the scores that come back. Okay, so use the course readings and journal articles. Every once in a while, if you find a decent practitioner source, that's okay. I hope everybody knows what a peer-reviewed journal is. Everybody's got a master's degree. I'm hoping. Yeah, the library is good, but I always start with Google Scholar, and a lot of times you can find the full text PDF on Google Scholar. And as I showed you in my Word EndNote demonstration in week 1, Google Scholar makes it super easy to collect resources and cite them appropriately within your work. So yeah, this fourth bullet: be clear with well-written, concise prose, excellent grammar, and style techniques. You are being graded in part on the quality of your writing. That comes straight from the university, guys. That is the writing expectation: excellent grammar and style. So choose your words carefully. As we're going to see here in a minute, you don't want to let someone else choose your words. And when you can or when you need a definition, we'll do blockchain later in the course, but right now we're doing data science and data analytics. If you need to define a term, please use the textbook. I see people citing things in their discussion posts. You're just sticking a citation in there to try and fill the square. You're just sticking a citation in there because the article had something to do with the topic, maybe. Um, and I've talked in my Word EndNote demo. I talked at length about that. You need to be citing sources that a big part of their writing was reinforced, or a big part of their writing reinforced the point you made in your paper. Some points need to be reinforced. Others are more obvious. And that's the art and skill of academic writing, is using an established author's findings or recommendations to bolster your own writing, to reinforce your own point. That's often lost on students. But if I email you and ask you what your source did uh, to, or where in your source they said something that reinforced your point, if I scrutinize your citations and your references and I send you an email, you've got a very short amount of time to answer my question before I'll give you a 0. So don't use fake citations, and you'll be fine. Okay, so that's the week 2 research paper. Those are the basic requirements. Again, the instructions are in the assignment in the classroom of exactly how I want you to approach the paper and what your headings should look like. So I'm really looking forward to seeing your work. Now, when it comes to headings, please pay attention to this. You don't necessarily need the heading level 1 centered with heading level 2 on the left side. You can use just heading level 1. If you've just got two big subpoints or three, you can use level 1 headings. And actually, I wouldn't mark you down if you use level 2 headings for everything, left justified. Yeah, there's lots of information on APA out there, guys. So make sure you're paying attention to that. But the main thing is I want you to provide maximum information and minimum fluff. And I'll go into that with the paper here in just a minute. So yeah, the conclusion of this presentation, there's lots of different terms that we'll go over this semester in data science, and they all kind of relate a little bit to each other, sort of. But we'll gain some clarity as we go through. And now, yeah, smart cities. This week, there's lots and lots and lots of good writing out there on smart cities and big data applications. But bottom line, when you're writing, focus on the requirements. Just like I said in my academic writing for systems engineers, man, do an outline. Think about what you're going to write. I use the APA paper as my outline, but I focus on the keywords in the assignment and I address the required content. Don't just write some generic thing. Okay, focus, focus, focus. And as always, please email me any questions or concerns. But right now, I want to go to this here document, which is going to require me to stop sharing that and share a Word document. Ha, here we go. Okay, now I just grabbed an APA Word, paper off the internet here. So like I said, you don't have to use this template, but I recommend it over using anything else because I've actually written this out and added some words to it. Okay, so there's your title, right? Choose a title. Change, of course, the name, the date. Make sure you put the actual due date of the assignment. Okay, so you repeat the title here. So again, these are 2-page papers, guys. Don't spend a lot of time. There's a combination of garbage from the paper that I used here and my own writing. So get rid of everything in here. Don't turn in really anything that you see in this paper, okay? Because it's a mixture of information and garbage. Okay, so do an introduction paragraph. Okay, in the beginning here, very short though. If you need to define big data, okay. If you need to define a smart city, okay. But don't spend much of a 2 to 3 page paper on introducing your topic, and make sure there is a thesis sentence. This paper will examine smart cities, blah, blah, blah. Make sure you have a thesis sentence. Okay. All right. And then here's example of headings, a heading and subheading. You can get rid of one or the other, use one or the other. You can use, 2 or 3 of these headings throughout the paper. Heading 1, heading 2. So they're just there for formatting so that I can understand where you're covering what part of the assignment. But I do want you to look at this though. I copied recommendations for an introduction paragraph from this Ashford University. And I pasted that in here and I formatted the subheadings, level 2 headings. And all of this first under heading 1 is verbatim from that website. I did a bulletized list, which is APA format. They had, I think, three subtopics and a couple of bulletized lists. Okay. And then I ran it through an article spinner. And it might pass safe assign, but I'll give it a 0. Um, when I see writing that does not meet the standard that the university sets forth, as in the syllabus, um, I kind of look at it, and when there's really weird grammatical issues and poor word choices, I know it's an article spinner. And even if it's not an article spinner, it's something that was found online that came from an article spinner. So choose your words carefully. Look at this bold text here, please. Please write all of your text yourself in your own words, beginning with a blank document or this template. All right. Last semester, just here a few weeks ago, a student turned in a draft paper to me that had a large section, like an entire page, that was stolen, ripped off from another student paper from Course Hero or Study.com or one of those horrible, horrible places. And she turned it in, and Safe Assign identified it, and I looked at it, and I looked at the previous student's paper, and I asked, "What in the world's going on here?" in email, and she said, "Oh, I didn't realize you were going to run plagiarism checker on it. I thought it was just a draft for feedback, and I put that in there to work on it. I put it in there to work on it." So she had cut and pasted someone else's work into her own paper to work on it. And that is cheating. And it's going to result, you're going to mess it up. Whatever, no one said anything good that you're going to be able to reuse unless you reuse it so much that it's cheating. Like if you find, I think I asked this question from one previous section, and probably some of those cheaters um, uploaded it. I haven't looked yet. Um, so anyway, uh, yeah, article spinners. You don't begin with a snare, you begin with a hook. Nobody says snare. And you're a peruser. It's your reader, okay? And if I see the word, I swear, if I see the word large information, um, I'm going to do everything I can um, to correct the situation. All right, so there you go. And everybody needs a conclusion paragraph, and you need a few academic references on a separate reference page. Okay, so keep it short, keep it settled focused on the instructions, and write your own material. Okay, and choose your words carefully. I think we've already seen some examples in the discussion this week where people are not writing originally and not choosing their words carefully. And you're wasting my time, you're wasting your colleagues' time, and you're wasting your own time, most personally. So there is that paper. So, all right, guys, this is your first go round, your first graded research paper with me. I'm probably not like any other instructor you've ever had. I actually read your papers um, and make substantive comments and give you substantive feedback. If you're used to dealing with other professors that you're turning in garbage and they know you're turning in garbage and everybody looks the other way, that's probably not going to work this semester. Okay. So just fair warning. All right. Um, I look forward to good papers. I'm an easy A. I really am. I'm an easy A for students that actually want to work and and learn and be a real PhD instead of some guy that just got a piece of paper and has no idea what they're doing. So I look forward to working with. I can already tell from the discussion, some of you are fantastic, and I look forward to working with you. Okay, so that concludes the week 2 lecture.